Hello everyone, this is Dr. Zach. Today in AP Calculus we're going to explore particle motion. This includes velocity, acceleration, distance, and position. So for today's lesson preview, you needed to determine the velocity and speed of the particle at t equals 3. What you should have recognized is that both the velocity and the speed were equivalent. Make certain that you are also using feet per second in this particular problem. For question B, how high will the particle go? In order to figure out how high a particle go, remember that's where you have horizontal tangent lines. So you took your derivative and you set it equal to 0. For question C, the speed of your projectile when it hits the ground. Now, when you hit the ground, that means that your distance is 0. And the velocity at 7 was negative 112 feet per second. However, the speed is always positive because speed is the absolute value of your velocity. So keep in mind, speed is always positive. Horizontal motion wasn't a whole lot different. When you were looking for the velocity and acceleration of your roller coaster, you found the derivative of your distance and the second derivative of distance. When is the roller coaster stopped? For the roller coaster to be stopped, you have to have your derivative is equal to 0. Now, this next question is a little bit more interesting. When is the roller coaster speeding up? So when you're speeding up, that means that your velocity and acceleration have the same sign on that interval. So where did velocity and acceleration have the same sign? So check your answers on the preview. Do look at part C on question B. The speeding up, there are actually two parts in which we're speeding up because remember, your velocity and acceleration have to have the same sign, and that occurs between 0 and 40 and from 80 to 120 seconds. So we're speeding up on the interval 0 to 40 and 80 to 120. As we further explore particle motion, we want to think about position, velocity, and acceleration. Now, S of t is often used to denote the object's position. This is relative to the origin. The position can be a vertical distance from the origin or a horizontal distance from the origin. When you combine these two concepts, you're getting into multivariable calculus. Now, velocity is the rate of change of position over time. And so that would be the derivative of your position function, or ds/dt. Velocity is often measured in feet per second or even meters per second. There are various ways to measure velocity, but it's always going to be some sort of position divided by time. Now, as you further break down velocity, if your velocity is positive, your object is either moving to the right or it's moving upward. If your velocity is negative, then you're either going to move to the left or your object moves downward. When your velocity is equal to 0, the object has stopped. Now, speed is the absolute value of your velocity function. So speed is always positive. Keep that in mind as you work through your problems. Example 1 describes how to graph horizontal positions. So you're asked to graph S of t given 5 different values for t. So we will make a table for all of this. We have 0, 1, 2, 3, and 4. Substitute your values in. You have negative 3, negative 4, negative 3, 0, and 5. So as you can see, when t is equal to 0, we're left of the origin at the position negative 3. When time is 1, we're at the position negative 4. And as you plot these points with parametric equations, you want to fill in the t values as you go forward with your graph. Now, the graph does turn around at t equals 1, so that should tell you something about the velocity at t equals 1 just from looking at this graph. And for t equals 3, we're back at the origin. And for t equals 4, we are to the right of the origin in a position 5 units away. When you graph it, connect the dots. This is a continuous function. And we also want to put the orientation in for our position graph. So now let's take a look at example 2. For example 2, we're asked to describe when a car is moving forward, backwards, or stopped, and we're to use the graph to justify our answer. Make certain that you understand what the graph is describing. In this case, we're looking at a velocity graph. I need to know when the velocity is positive, negative, or 0. So I'm going to draw a number line to organize my information. On my number line, I'm going to describe, look at this. The velocity is below the x-axis and therefore must be negative between 0 and 3. Now your velocity is above the axis from 3 to 5, so that must mean that the velocity is positive. And then when we're below the axis from 5 to 6, that would tell us that the velocity is negative. Now once you know when your velocity is positive and negative, you can interpret the graph. We want to make certain that we justify our answers as we answer the questions. So, for example, since the velocity is greater than 0 on 3, 4, the car moves forward on that interval. Since your velocity is less than 0 on 0, 3, union 5, 6, the car moves backwards on that interval. And lastly, since velocity equals 0 at t equals 0, 3, and 5, the car was stopped at those values. All right, so it looks like we have a lot to write, and you're right, we do. Now, the components for writing one of these statements, you want to give why something is happening. You want to say where the thing happened. And lastly, you want to say exactly what was happening at those intervals. So there's 3 parts to each statement: the why, where, and what. Next, we're going to talk about acceleration of a particle. So acceleration is the derivative of your velocity, or of course, it's going to be the second derivative of your position function. This can be relayed as dv dt or even d squared s dt squared. When you measure acceleration, think about the units. It's going to be meters per second squared often, or you could have feet per second squared. So it's a position divided by time squared whenever you're thinking about units. So what's happening? If your acceleration is 0, that means your velocity is increasing. And if your acceleration is less than 0, your velocity is decreasing. At times, though, your velocity is not changing at all. And if it's not changing at all, then your acceleration is equal to 0. So when we think about acceleration, let's look at example 3. We have a graph which describes the velocity of our, we've seen this graph before. We want to describe now when was the car accelerating, decelerating, had a constant velocity. And we're going to use the graph to justify this answer. So once again, I'm going to draw a number line. I use my number line to keep my information organized. In this problem, I want to know when is the velocity increasing or decreasing. And the velocity is going to be increasing or decreasing depending on the slope of the line. So as I'm looking at my velocity graph, it seems to be decreasing until I get to 1. So you might disagree with this, but it's a little bit flat between 1 and 2. So it's not really decreasing or increasing there. I'm going to call that close to 0. It's for demonstration purposes. Now, once it hits 2, it looks like my velocity is increasing from 2 until 4. So velocity is increasing. And then as we go from 4 to 6, my velocity seems to be decreasing. So there's a lot going on in this graph with respect to the increasing, decreasing components of your velocity. So the statements we want to make, we want to discuss whether or not our car is accelerating, decelerating, or constant. So as we make our statements, look for the 3 components. You want to make certain that you're describing what's happening with the graph. The velocity is decreasing, where something is happening, and answering the question. The car's decelerating on these intervals. So look for all 3 pieces. Since the velocity is increasing, here's the interval, then the car must be accelerating. Since the velocity equals 0, the intervals or points for which this happens, and then what that means. Your velocity is constant. So you need all 3 components in order to answer the question completely. Now let's take a look at the relationship between velocity and acceleration. It's used to describe motion, or where the car is speeding up, slowing down, has a constant speed, or perhaps the car has stopped. So if your velocity is positive and your acceleration is positive, then your car is speeding up. If both the velocity and the acceleration are negative, your car is still speeding up. So when the signs of your velocity and acceleration are the same, your car speeds up. However, if your acceleration and velocity have opposite signs, then your car is slowing down. If at any point your velocity is equal to 0, your car has stopped. If your acceleration is equal to 0, in example 4, we're going to describe the motion of the car. Now, we've been talking about this velocity graph. You know when the velocity is positive and negative. We also know we have information about the acceleration. So when you describe the motion of the car, you want to describe whether or not your car is moving left or right. So we've talked about that. We want to know about the velocity graph, which we've also talked about, whether the car is accelerating or decelerating. The third component of a particle problem is a discussion about whether or not the particle or car is speeding up or slowing down. So you want to make a statement about your graph's velocity and acceleration, where they have the same sign, whether they're both positive or both negative. Make a statement about the interval for which this occurs, and then the car is speeding up. You also want to make a statement about where your velocity and acceleration graphs have opposite signs, the interval for which this occurs, and then a statement that your car is slowing down. So 3 components that you want to discuss when talking about particle motion. You want to talk about the position of your car, whether it's moving right or left, whether or not your car is accelerating or decelerating, and as well, you want to discuss whether or not the car is speeding up or slowing down. Please include when the car has stopped as well. So for example 5, we're going to do an analysis of the particle's direction, acceleration, motion, and position. Begin by finding S prime of t. So S prime of t is your velocity function, and that is going to be, in this problem, 3t squared minus 18t plus 24. We're also going to need the acceleration function, but before we find that, let's do some factoring, because factoring is going to make this problem a lot easier to analyze. So we have 3 times the quantity t minus 4 times your t minus 2. We're also going to think about the acceleration, and the acceleration is the second derivative of your position function, or the derivative of velocity. They're all equivalent. And the derivative of our velocity is 6t minus 18. And if you want to factor it, 6 times t minus 3. So let's make sign charts so that we have a good understanding of what's happening. Now, a sign chart is used by yourself. The sign chart will not be sufficient justification for your answer. It is only used to help explain to yourself the intervals for which things are increasing, decreasing, not moving. So use the sign chart to help organize your thoughts. Place your velocity graph sign chart and your acceleration sign chart on the same number line so that you can get a really good idea of where your function is speeding up and slowing down. So make certain you have your positives and negatives in the right positions, and then we will be able to talk about speeding up and slowing down. You can see that the velocity is positive to the left of 2. That means that your function is moving to the right. And where it's negative, it's going to be moving left. Your acceleration's talking about deceleration and acceleration. When you put it all together, when the signs are the same, that's where you're speeding up. And when they're different, that's where you are slowing down. So signs are the same, speed up, slow down is when the signs for your velocity and acceleration will be different. All right, so once you have all the information in one place, you then make statements. Your statements should be relative to your question, so talking about direction. The particle is moving right, here's the interval, because the derivative or velocity of is greater than 0 on that interval. Your particle moves left, here's my interval, because the derivative is less than 0. The particle has stopped and switched directions at t equals 2 and 4 because s prime of t equals 0 there, and switched signs at these values. Notice I use s prime of t. I could also have used v of t. I do not use pronouns such as its derivative or the graph. Be very specific when you're speaking about your function. For the second part of the question, acceleration, talk about where your particle is accelerating, give the because, and the interval this occurs on. Same thing with deceleration, and where the particle is constant, because that is where your second derivative equals 0. Now, speeding up and slowing down occur when your first derivative and second derivatives have the same signs. Now, this one is actually a typo. It should say s double prime of t, s double prime of t. So fix those typos. And lastly, talk about position. And when you talk about the position, you can talk about its initial value, talk about where it's moving to the right or left, give some specific points, and that would be the idea about the positions. All right, so now we're going to put it all together. When you are discussing a particle motion problem, you should probably determine your velocity, figure out where it is equal to 0, use a number line to show where the object has stopped so that you have positive values for velocity, negative values for your velocity on that number line. Determine where your acceleration is equal to 0. Once again, use a number line to show the zeros, positives, and negatives of acceleration. And then create a motion number line where you're going to put all the information together. Now, these number lines, once again, are just for you. It is the words, when you justify your graphs, that is the part that we will be looking for when you explain your answers. So you have about 4 problems to work on, and work for 15 minutes. Once you've completed these 4 problems, review your answers on the completed note sheet. Notice that velocity problems can be given to you in the form of graphs and through the form of datas, and you should be able to answer the question using both of these ideas. Now that you've spent a little bit more time practicing your particle problems, remember to review for your test. Begin on page 157. Work on some of those even questions. If you prefer to complete the odd questions, that's fine. Just get some good practice, please. And that's it for today's lesson. You have a fabulous day.